This is Her Majesty Easy World Science Channel. In this video, we'll be looking at Ganong's Potometer, the glass apparatus used to measure the rate of transpiration, that is the rate at which the plant takes water, the shoot of plant absorb water, or the uptake of water by the shoot of plant, and also to confirm what we call the transpiration pool on the rate of absorption of water by the plants. Okay, so Ganong's Potometer, the parts, as you can see here, is made up of the reservoir tube, the end tube, and the capillary tube. Then there is the supports, which will stand each of them. We have the two sets here, one for the experiment, one for the control experiment. Then we have small beaker, not calibrated, to carry the water from which the capillary tube is inserted to draw water from. So first of all, you see the tap for the reservoir tube. Then you connect a twig. The twig of plant should be disconnected, or rather cut off from the plant, and then inserted into water. The ideal thing is to cut small parts on a slanting position underwater to avoid air bubbles from moving into the xylem. But here I did it without inserting into water, but I inserted it in water, washed it properly for us living in a dusty area to remove the dust covering the stomata. Then you have to fix this twig into a rubber stopper that you have drilled a hole, and make sure you try your possible best to remove any air bubbles that have entered into the xylem. Then you have to seal the rubber stopper and the leaf with what I have here is a paraffin wax, of course, to prevent air from moving in, because the major secret for you to make Ganong Potometer functional is to make sure that there is no leakage, no air gets into it except from the end of the capillary tube. If air moves in through the twig at the end tube, it will not create that suction pressure. So you make sure you seal off, as you can see there. Then the next challenge is to fill this Ganong's Potometer with water. How I do it, I add small water at the end tube and add at the reservoir, then open the reservoir, the water, having it in a slant position. After this, you make sure there won't be any air bubbles or much air bubbles around this Ganong's Potometer, because it will affect the suction. Then I held the twig here with another clamp because it is big enough. I want it to create enough suction pressure, so wind will make it pull the Ganong's Potometer down. Then when you set this up, as you can see, there is air bubble drawn in at the end of that capillary. I have to fill the beaker with water. Normally we're supposed to color the water with eosine, but here just place it, you see, created enough suction pressure. You see the air bubble. You look at the mark in the beginning, which is 16.5 millimeter. So this is measured, as the capillary tube is read in millimeters. So it started at 15 point something at the end. The bubbles, I hope you can see well. I discovered that some people don't see the mark well. Therefore, after this, I repeated the experiment with eosine. Then after 30 minutes, the reading was taken. The air bubble was at 14.5 mm, so which means that the twig has started sucking water. And I placed this near the window in the laboratory to make sure that wind gets on the leaves. Remember, one of the factors affecting the rate of transpiration is wind, apart from temperature, so, and availability of soil water also. So you still see that the Ganong's Potometer is well sealed. Now this is a control experiment. There is no twig, therefore there is no suction pressure or transpiration pool created from the beaker. There is no air bubble at all, and it's not rising. Therefore, the setup is read in every 30 minutes. And let's see the next reading here. Then after some times, I have to fill the water again, fearfully thinking that they might finish up. That led to the spillage of water. I have to dry everything because the water beneath the capillary tube will reflect and affect your reading of the point of the air bubble. So the air bubble now is gradually getting to 14.3 millimeter. Then we will take our reading in the next 10 30 minutes or 1 hour. So let's see what it gives us in the next reading. Okay, after 1 hour, it gives us 13.80 millimeter. The breeze from the window dropped a bit, so as the breeze is increasing, if you place it near the window and breeze is coming from the window, you can see the rate of transpiration is high. Look at the mark of the air bubble heading towards 13. So you can calculate the distance covered. We started from 15 point something in the 0 time. Now we are in the 13.8 or 14.8, if I'm correct. So we are taking a reading after 2 hours. It moved to 12.5 millimeter at 2:30. We started the experiment at 12:30 p.m. Now it's 2:30 p.m. So after 2 hours, you see the distance covered. Then I left this overnight, starting from the 2:30 to 8 a.m. the next day. Guess what? It moved almost to 0 mark. That's 0.1 millimeter, and the maximum capacity in this is just 20 millimeter. Now I repeated the experiment to enhance visibility with eosine. The beaker has water colored with eosine, so that as the water rises into the capillary tube, one can see the mark. There is 2 marks here, which is the air bubble mark 14.0 and eosine, the red mark 15.7. Which one can we read? You can read any of them because they move at the same rate. If you like, you use the red position, the eosine, or if you like, you read the air bubbles. As far as you don't alter it, they move at the same rate. They are always separated by 1.7 millimeter apart, as you can see. So let's see the next reading after 13 minutes. The air bubble point is at 12.60, while the eosine is at 14.30. So the reading keeps the 1.7 distance constant, and as you can see there at the screen, the eosine is indicating the position of the water being sucked up from the beaker. What is actually sucking this is because the plant is losing water through the stomata, and that creates a suction pressure from this beaker colored with eosine to enhance visibility. Now after 1 hour, air bubble is 11.40, eosine is 13.10. As you can see there clearly, still kept at the window in the same position I kept the other one. So the little problem here is that the liquid might take some time to arrive from the mark that you can read, but you have to be patient. Sometimes you can tilt the cork a bit. Thank you for watching. Don't forget to subscribe and share this video. I cannot do without you. Bye for now. Much love.